Welcome to today's webinar titled Predictive Analytics is for You. This webinar has had a lot of interest, and we're excited because I think predictive analytics has had a lot of visibility, and there's been a lot of confusion about how business people can use it to make better and quicker decisions. And this webinar has a couple of case examples from Dartmouth and UPenn focused on fundraising, but the principles go well beyond. And what we're talking about today is applicability to healthcare, to consumer marketing, to trading and analytics, to network and security. A lot of the different areas where Advisor works, these principles apply. But in order to get some focus around specific problems, this drills in on higher education fundraising. The agenda for today, we're going to spend 5 minutes talking about what is predictive analytics, and I'm Doug Cogswell, President and Advisor, and I'll be the moderator here. And then we're going to do a demo, a short demo where we're going to look at finding million prospects. And then Dartmouth, Mike Foote, who's the Director of Research, is going to talk about the kinds of things he's used it for in his real-world experiences and line. So I might just say hi here.
Hey, how you doing?
Yeah, you'll hear more from him in a few minutes. And then from UPenn, we've got Danalisa, who's going to talk about how they've used it in a number of areas. Hi, Danalisa.
Hi, everyone.
Yeah, thank you guys for joining. And then we're going to have a Q&A session at the end. We'll be able to unmute participants. So if you have questions, you'll be able to ask them live to Mike and Danalisa. So first, let's look at predictive analytics. The concept here is using mathematical tools and algorithms to examine and determine patterns in one set of data in order to predict behavior in another set. And this integrates well with in-memory data and data visualization. And the concept here is you select a target, which in this case we're going to select current million-dollar donors. You then compare it to a base population, which in this case is going to be everybody else. Then we're going to examine explanatory fields, which are, there's a concept of the core table, which in this case will be the entities or people or customers or prospects, however they're called in different problem areas. We can bring factors in from other tables. We'll talk a bit about how to do that because maybe there's something, certain people had MBAs or they were CEOs of companies or they participated in certain events, and that's relevant information we want to put into the model. It's a regression-based model. And then what the model does, it does what's called correlation. So we'll look at the explanatory factors and try to figure out which ones are aligned most with the target population, which makes that different. And there then needs to be a discussion, which is where people come in, because correlation may not always be equal to causation. And we'll look at that in a little bit. So the model figures out the correlated factors, and then the team works with it to figure out what really matters. And it's an iterative and collaborative process. And I want to really stress that one of the reasons I think this is really valuable for teams is the team that owns the data is the best capable of doing this, where you need to think about what's the right target, what's the right base. You can visually explore the data to figure out, kind of you're trying to form hypotheses about what makes the target different than the base. Then you need to carefully select a list of explanatory fields. Some of them, like if you're selecting million-dollar donors, the fact that they gave $1 million is not an explanatory factor and needs to be removed. Or maybe if they're staffed by certain people, they were staffed because they're large donors, that's not a causal factor. That should be removed. The model will try to figure this out, but you need to think about this and this difference between correlation and causation and get out the ones that are clearly not causal. Then you build the model, then you see the output, and then you iterate it. This typically is a 2, 3, 4 time cycle pass through the model to make sure that what's coming out makes logical sense. And this is best done, in our view, in a collaborative process with a working team at the customer, not by outside consultants who don't know the data, don't know the context as well. Out of this, you get a list out of the model of what matters, what's causing this target to be different than the base population. Then point 7, you can use the model to predict and score the other people to figure out who have the same characteristics, who have not yet been million-dollar donors. Those would be the list of potential targets to go after with the team. And you can picture this process could apply to medical claims. What are the outliers? What are the characteristics? Which ones do we worry about? It can be used, as I said, in a variety of other industries in similar ways. So one of the points we want to drive here is this is best done with your team, not outside consultants. And I think there's been this perspective that this is, a tricky process, so we need to farm it out. It generally costs more money. And I think one of the points we want to emphasize, this is not a black box process. It's not like, here's the data, back comes the answer. It's a process. And the reason it's hard to farm this out is because your team knows the data the best and also the context. And what we try to do with the software is make it easy to use the software so you don't need a statistics degree. And that means that then the key is knowing the data and the context is the important factor of getting this work right. Just a couple of examples. And Mike, you may add more on this when you talk later on, but I remember we were doing some work up at Dartmouth, and one of the factors that came back for financial aid giving was they had an interest in scholarship and financial aid. It looked like a causal factor. It was clearly correlated, but in the room, I think it was brought out that, no, that factor is put in the system after they've already given a large amount of financial aid, so it's correlated but not causal and needed to come out. And that's the context. An outside person is not going to know that. Your team will know that as they wrestle with it in this iterative process, and you're going to get a better answer. The model will be aligned with the things that really matter versus the things the model finds are correlated. And as we go through this, I think that's a key point that just is really important. So now we're going to look at a demo just to set up how this works. And we're going to explore who have historically been my best donors. Who else fits that same profile, and out of that list, who are currently rated, who's staffed, who's attended an event recently. And I want to point out this is an illustrative example using disguised data. The names have been changed, amounts, and so forth to protect the innocent. So the concept is advisor puts data in a dashboard, and this is an example of a 10-page roughly dashboard. The first page is a list of all the prospects. There's 94,000 of them. There's some filters, and there's accounts showing what you're looking at. The thing you have in a lot of these areas is there's a lot of data and a lot of tables. And in this case, there's demographic data, there's affinity capacity data represented by some of these cubes. There may be activities people participated in, there may be giving data, and it may be in different forms and sources. So what our software does is it takes those tables, and there may be 10, 5, 20, 40 of them, knits them together in a memory pool, so it's all in memory, all available, all related to each other. And then to answer questions like who are my top donors, you can pull pieces of data from the different tables on the fly really easily. So back in this case, we started with the 94,000. We want to look at the giving history. We want to find who are the largest donors. And there's 94,000. There's a list of them. Together, they've given $1.6 billion. The biggest donor has given 40,000. It ranges down the bottom of the list. There'll be some who haven't given much. And then there's we've created some filter bins for how much they've given: $1 to $99, $100 to $400, $50 to $100,000, $1 million to $2 million. So what you can now do very easily, and we call this visual discovery, use the mouse and just sweep over these bottom boxes, which has grabbed the 237 people who have given a total of $958 million, which is a substantial part of the total. And here's the list of them. And here's their giving history, which actually looks pretty good. It's gone up over time, but those 237, the number of gifts have gone up. So this is a good situation. Now, we just selected the target, 237 entities who have given $1 million. We want to compare that to a base population, which is everybody else, the 94,000. We want to determine what makes the target different than everybody else, and then predict who else fits this target but haven't yet given $1 million. And on explanatory fields, the way a model works is it runs against one table at a time. And in this case, we're going to run it against the core table, which is the list of people. And in that table, there's biographical and geographical information. There's affiliation, where the alumni are parents in this case. What class year, how are they rated, scored. So there's a set of fields. But there's a set of other fields in the other tables that we bring into memory. For example, degrees. If you're looking at $1 million donors, maybe if they have an MBA or an MD or a JD, that matters. Or employment. Did they have a C-level job? Did they work in financial services? Giving. The number of years they've been a donor. The maximum gift size. The number of years since they gave that maximum gift. Or maybe events. How many events have they attended and the last attended? So one of the things as we're building a model is the hypothesis setting stage. We can think through other factors in these other tables. And we can quickly calculate out of the degrees table, the people who have an MBA and join it into the core table in memory, not having to touch the Oracle databases this data comes from, and then you have those factors to work with in the model. And since it's iterative, if the factors don't matter, you can take them out. If you run the model and you go, well, wait a minute, I see these factors, but maybe the type of degree really matters. And maybe you did see that looking around at some charts in the dashboard that, looks like some of these degrees matter more than others. Very easy to create the factors and bring them into the model. And then you can also then run the model, say, against the events table. If the number of events and last attended makes a difference, you might want to run the model for those 237 against just the events table, which will rank the events for their most likelihood to produce $1 million donor. And some of them may have a negative correlation. You'd like to know that. We did some events that actually reduced the probability of people making a large donation. Now let's actually went on a tangent there. Let's go back to the demo. So we selected our $237 million donors by just sweeping over the bar chart. That's the target. There's a panel. We're going to click on Predictive Modeling, and it brings up a modeling panel. And then there's 4 steps to build the model. You have to give it a name. So we typed in $1 million donor. That's a good name for this model. You have to set the target. You can either target data columns in the table or just the currently selected rows, which are the 237 we selected in the prior chart. Then you go through and exclude factors that are not clearly causal. So you might want to take off next action date. You've got all these staff names. Well, we know the staff were assigned by the type of donor, so let's get them out. We've got things like the spouse ID is clearly not causal. If the spouse is an alum is causal, we leave that in, but the ID is not causal. And then we have to take off, since we selected the lifetime giving, we need to take that out. Now, if you miss this, you'll catch it on the next pass, because if you left total lifetime giving in, the model's going to tell you total lifetime giving determines 100% of this group, and you have to rerun it and take it out. Very easy to do. But now we click Run the Model, and it gives us some results. It tells us over here that if they've given to the alumni fund for 6 years, that explains 24% of this group. Now, that's obviously related to large giving, so we might want to take that out and rerun the model and look at the other factors. If they've been contacted, and it's recently, who contacted them, their rating, the spouse is an alum is a factor. So this starts telling us what makes up these people. And for each of them, like alumni fund 6-year total, the one that's highlighted, it buckets into bins which groups of, it bins it into groups that are most correlated. So the $50,000 and up is the most correlated. The $800 to $50,000 is the next bin, and then small amounts are lower. In fact, it looks like if they gave 0, there's like minimal amounts are worse than if they gave nothing. So you may be able to you can probably read a lot into this, but this factor I would probably recommend take it out because it's really related to total giving. Rerun the model, but we've run the model. Now you click Predict. And what Predict does is it applies the model to the other 94,000 people and scores. So it sticks fields in the core table about their probability to be major donors, $1 million donors. And we found 176 additional $1 million donors. And we have a list with the names. This could have IDs, addresses, whatever. There's a selection. So this is binned. If there's a 1, they're predicted to have the potential to be $1 million donor. If they're a 0, they're not. To also give a ranked scoring. So within the ones, you can order them from the most likely to be $1 million to the least, which is probably how you would want to target this with your staff. And so you can export this list out, and so here's a target list to really focus and go after. Now we want to explore them. So the rest of these pages are descriptions of the people. We've got ratings, affiliation, where they live. So here's the 176 people. Here's the amount they've given. They've given a total of $24 million already. Some of them have given close to $1 million. If you roll down the list, some at the bottom have not. Look at the ratings. These are scoring metrics. 50 million or more potential. 1 to 4 million. Well, half of them are scored to be 1 million plus donors. The other half are scored to be less than 1 million plus donors. So we probably want to explore this, but at least they're rated. and you look at staffing. They're almost all staffed. That's good news. So we can get a message. Let's up maybe the ask amounts or explore these some more. Who are they by affiliation? So the affiliation page is a bar chart of class year. You can see there's a cluster in the 50s, but the vast group of them are in the 80s. So there's some affinity to this group that fits the model. You also see down here they're heavily alumni and some parents. They're not friends and grandparents and other stakeholders. Where do they live? So we look at a map for the 176. Well, there's a cluster. New York has 37 of them. New York City, there's a group up around Boston. There's some in South Florida. This could be explored further. This might be, you could hypothesize older. Sweep over that. You could go back and look at class year. So in summary, it took 30 minutes to do this analysis in real time. You don't need a statistics background. You'd probably iterate a few more times than I did there. But we found 176 prime prospects, assigned the 4 who aren't staffed, up the rating on the 50% who aren't at $1 million level, at least explore that. Maybe you want to plan some events in New York, maybe around Boston or South Florida with this group, and leverage themes, affinities from the 80s because it's where they lie. And this is just an example of how predictive analytics can help you understand what's in the data and the stories that it tells. It's not hard and fast, but gives clear indications and gives some direction. So now let's look at a couple of case studies. Got Mike on the phone. He's going to talk a little bit about background working with advisor, example 2, and this is going to be interactive, and Danalisa is also on the line, can talk back and forth. So we'll let Mike talk for a few minutes, then Danalisa, then we'll go to Q&A. So Mike, you've got the mic.
Great. Thanks, Doug. That was a good, clear summary of the how predictive modeling works with Advisor. Just to make a full disclosure here, I actually do have a statistics undergraduate degree, but I have to emphasize that I am by no means an expert statistician. But I feel comfortable enough to have a basic understanding of how to interpret the results, how to articulate the results to upper management and to field officers, and really how to utilize the results as a starting point for any decision making. And I'll talk about some of the different projects we've used Advisor for. So we've been working with Advisor for probably 2 to 3 years now, and when we first started using it, we were doing basic sort of data mining type projects and using it to create descriptive models of our donor segments. So we've done, here's what a $1 million donor looks like, or here's what an arts donor looks like. For the past 9 months, though, we've been pretty consistently utilizing the predictive modeling tools within Advisor. And a couple of examples of what we've done there include doing sort of typical pool reviews, portfolio reviews with field officers. So using the predictive modeling to highlight those prospects from an analytical standpoint, from a very objective standpoint, look like those donors that we should be paying the most attention to. And we'll use the results of the predictive models as a complement to the subjective insight that field officers naturally bring to their donor pools. And as a result, we've been able to streamline and reduce the size of portfolios pretty dramatically in some instances, going from 300-plus pools down to 150 in many cases. But those 150 are very targeted, high yield in terms of ask amounts to granted amounts. And it just provides the field officers with less of a burden in terms of pool reviews and so on, so that they just feel like a big weight has been lifted from their shoulders, and they can now focus much more strategically on a smaller pool. We've also used predictive modeling to highlight the best prospects for fundraising and fundraising priorities, in particularly financial aid, and Doug talked a little bit about this. Our first cut in looking at who the top financial aid prospects might be, we were able to identify 1,400 prospects that look like outstanding donors towards financial aid. And in the end, I think my numbers, let me check. Yeah, we're able to identify and grab an additional 300 gifts towards financial aid in just the last quarter of our most recent campaign. And the key to Advisor and having the data here and being able to create and massage the predictive models within Advisor, it allows us to do it in real time, and it allows us to refresh those models on a quarterly basis, which you can do it on a weekly basis. We found that doing it on a quarterly basis makes the most sense. And this allows new prospects that perhaps circumstances have changed. They've suddenly popped up on the radar. All of a sudden now they're popping up on our in our predictive models. We've also begun using predictive modeling to highlight for our annual fund those donors that are most likely to be $100,000 reunion givers in any particular reunion year. And this is helping the annual fund director set agendas for her meetings with individual field officers in assigning who solicitors should be and what reunion ask amounts should be. So we're finding a lot of new prospects that way as well. And then, so, you know, what I see going forward, let me just touch on that as well. We just recently finished our most recent campaign where we raised $1.3 billion. So now a natural fit for this predictive modeling is utilizing it for some of the post-campaign analytics that we'll be doing. So, you know, looking at pool sizes, what's the optimal pool size for any one field officer? Did events all throughout the campaign make a difference in fundraising? All of the different annual fund appeals that we've sent out, which were the most effective, and what can we learn from that going forward? And then still going forward, starting to use predictive modeling to help us make solicitor-solicitee assignments at the annual fund level. There's certain alum volunteers within the annual fund that are just phenomenally successful in raising gifts for their classes, and what are they doing right that perhaps other volunteers are not doing right, and how can we learn from that and use Advisor to allow us to, going forward, make smarter solicitor-solicitee assignments. So I'll leave it at that and sort of toss it over to Dana Lisa.
Mike, just a question.
Sure.
Because I know, could you just talk a bit about your team and collaboration by going through this process versus what would have happened if you had farmed this out to, say, an outside consultant? How do you kind of A/B the two? Because I know in a lot of cases we see organizations farming this stuff out to get the work done versus doing it in-house.
Well, I think, you know, you touched on this a little bit earlier. We in research just naturally know the data so much better than any consultant could possibly know coming in from the outside. And so we're able to build those models and massage them as we go along much more strategically, as well as we're building these models in collaboration with primary staff officers in many cases and with the director of the annual fund. So there's buy-in immediately from them as opposed to the researchers working closely with an outside consultant, and many times, and we've done that, and we've had some success there, but I think the buy-in is always harder once you get those models back to sell them and to have field officers and directors of some of the major gift offices begin utilizing them.
Yeah, good. And because one of our sort of things we've seen is, back to the point earlier, is the critical constraint is knowing the data in the context of the data much more so than the, you know, the statistical skills or whatever. Because there are a lot of really rich statistical tools out there, but they require, you know, a lot more statistics or math background. You might just say, could you say just a few words on how easy or hard it was for you to come up to speed on using this level of modeling?
Pretty quickly, as a matter of fact. Now, with my statistical background, you know, I felt, I think, more comfortable initially in utilizing it. But given lack of resources, what I've been able to do is sit down with our director of the annual fund, and this is probably a better example than my immediate reaction to the predictive model. I was able to sit down with our director of the annual fund, who really does not have any statistical background, sort of walk through the building of a couple of models based on, okay, who looks like your best $100,000 reunion donors. Walk through the building of those models one or two times with her, and she's off and running now, building her own models, sort of has some check-ins with me, but really is on her own, creating her own agendas for her reunion giving committee meetings, and is consistently highlighting new prospects on her own. And that was, 2 weeks tops, where across 2 weeks, maybe meeting with her one or two times for 45 minutes each time.
Well, yeah, I actually had not heard that story. That's a great one, and certainly what we're trying to empower is people who are trying to make these decisions and know the data to be able to pick the tool up and use it to provide some quantitative rigor or some that kind of structure around the decision-making process.
Yeah, I think previously when we did outside consultant data models, the perception from field officers, from the annual fund gift class officers, and the annual fund director was that these models were so advanced that only the researchers knew how to understand them and how to utilize them. And now what we've done is sort of put this tool in the hands of those individuals, sat down with them for some quick training, get them to understand the parameters and the basics, and now they're off and running. Whereas before, I don't think they would have even touched anything with the word predictive or model in the name because of the perception that it was too difficult to understand or too labor-intensive to begin building them on their own.
Okay, great. We're going to come back at the end with the Q&A, so those of you on the webinar can put your hand up and ask Mike questions. I'm going to swing over to Danalisa from UPenn, and again, thanks for joining us today, and same kind of discussion. Go ahead.
All right. Thanks, Doug and Mike, and thanks to everyone for spending part of your morning with us. I'm Danalisa, and I've been a data analyst at Penn for over 10 years. I've worked in the development offices at the Wharton School and then the medical system. And just to give you some scope, I'm now in central development where we support 28 different areas, schools, and centers, responsible for data mining projects, data analysis, and predictive modeling. To be honest, we were not interested in the software for prospect pool management or even standardized reporting, but more for the predictive modeling component and the data visualization. In the past, we've run predictive analytics more manually, if you will, whether in Excel. We looked at SPSS or even just crosstabs because they provide, at a very basic level, a more intuitive understanding of what your data is telling you. But we did decide to purchase Advisor, and we've had it for almost 2 years now. So as far as how it's done, we do it internally from start to finish. We pull the data, we clean and condition it, and then we go on and build the model. The prep time is the most consuming part. And as data analysts, we have to concern ourselves with data integrity. So we're looking at bad or missing data. We're looking at nulls, deduping, and then truly just scrubbing the data for domain transformation, binning, and outliers. So once you've sufficiently prepped the data, you can begin to build your model. And you spend a lot of time conditioning the other data points to fit the model you want to build. So for us, it's a lot of ones and zeros, all binary, because conceptually, predictive modeling attempts to find correlation between a dependent variable and many independent variables. So you create the model in Advisor, which is based on regression analysis, as Doug said, and then you can go on and actually export your data. I like to go back and test the model as well, so you get a prediction value, a probability value, and from that, you can actually create a confusion matrix to spot check predicted versus actual. So in general, you build a model, and again, as Doug said, it's absolutely an iterative process. You have to let the data talk to you. You'll see when you build your model, and I think Doug's slide was 21. You can see some of the data points, and they may pop out as clearly irrelevant or just not causal, so you remove them and rerun. You can absolutely tell if something's off. For example, if you don't want to include rating as a factor because by default, that person probably already gave and they gave it a high level, so you remove it. And once you're satisfied with the coefficient distribution, and that slide 22 you can now see if anything is swaying impact, meaning if something's at the top and it has a very high percentage. What's nice is with this particular page, you can actually see lift, which basically shows the degree of positive impact versus random. So back to, if something's at the top with a very high percentage, hypothetically say 52%, and on this slide it's 24.6, but you can run a model and you'll have a very high first factor. And it might be completely valid, but what's happening is it will have a cascading effect and diminish proportionately the remaining distribution. And it's not always wrong. In the project I'll talk about, there was a very high first factor, and it was absolutely valid. But since it's weight numbers, I just noted the variable, removed it, and reran. So again, you have to let the data talk to you. You have to know how to interpret it and just keep going. The project I thought worth sharing was one I did recently for a vet school and hospital system. The data in that project came from two different sources. It was hospital client data and then also development data. A whole separate issue, which many people might understand, is getting the data to match and talk to each other because there were two different systems, and this was part of what made this project span several months. The goal was to identify potential donors based on existing client and donor data, and that's pretty broad in terminology, but that's a relatively standard goal in development. You want to find the right people to solicit. You try and cut your costs by mailing efficiently, and hopefully at the same time increase your revenue stream. And in an ideal world, that's how it works. Just as in Doug's example, I think Doug said he identified 176 targets. Our model for the vet program had some interesting output, and some of it we didn't foresee. There was 23 years of data on about, not too many records, 200,000. I guess that depends on the side of your whole data pool, but for us, we work with sometimes larger pools than that. And my belief is the more you have to work with, the better. I think it's better policy and practice to go broad and be able to refine from a larger data pool rather than to create a good model and then have to start over. And truly, for the work you do and the time this takes, you want to create impact. So as far as the outcome from this project, I expected to identify potential donors, and that happened. But as analysts and subject matter experts, we're supposed to know how to interpret what we see and where to go next. When I ran the model, there was one factor that had such a high percentage of contribution skewed the rest of the percentages, but it was absolutely valid. It was, did this person make a gift anywhere else at Penn before their first appointment at the hospital? And it was so powerful to see this because it told the folks at the hospital, if this client was a donor to anywhere else at Penn, the minute they stepped foot for their first appointment, they had over 75% chance of making a gift to vet after they leave. And that's powerful. So that's, and what that translates to the development officers, that's who you need to make sure you solicit. So that was only one thing that came out of this. Another striking outcome was that the model showed the disposition of the animals when they left. In other words, were they alive, deceased, or euthanized? That clearly impacted and correlated to, did that translate to donations? But not in the way we expected. You might instinctively argue or think that if someone lost a pet during their stay, so euthanized, they might not make a gift. And that's exactly how the annual fund program structured their solicitation. So they removed these folks from the mailings, just removed them entirely. But the data showed statistically that euthanized pet owners made substantial gifts within the first 3 years. And this was shocking. 3 years, and that's huge. It showed almost no activity in the first 6 months. And this is what the data is telling us. It's right there in black and white. But from 6 months to 3 years, these gifts were coming in, and these were unsolicited because, remember, they removed these people from the mailings. The return on this project was considerable in that it looked at statistical correlation of so many factors. And that's what kind of made this a fun project. We looked at breeds and species, medical treatments, doctor assignments, incentive programs, and other factors. And it was truly enough to suggest that some programs and policies should be revisited. So again, I mean, just to surmise, I think it's a powerful tool that we can all use to create impact for our clients.
Yeah, Dana, Lisa, what was cool in there was, there was a set of assumptions about the way things work, but there was,
right.
We used the word stories in the data that were there all along, but it was just uncovering them and understanding the causality of one thing to another, which was an unintended observation or consequence that resulted in good benefits.
That's absolutely true, and this is the data discovery where it's not that anyone's wrong, because at some point we all create our programs based on experience and instinct, and that's what's so fantastic about when you truly just start digging into your data. It will talk to you, and it's just you might say, well, should we revisit this? Maybe this needs to be changed, but we'll absolutely leave this intact. So it's very interesting, and because what happens is when you start one project like this, because truly the applications to me of this are almost endless, but you go in perhaps with just one goal, so find your next big donor. But with all this data, and like I said, my suggestion is pull in more. More data is better than less, and you'll go on tangents. I think it was one of your slides where you said go back and now drill down to which event had impact. So I mean, it's exactly what you're saying. It just sort of springboards into other things to investigate.
Yeah, Mike.
I would just add to that, and I think you both touched on it, is how the predictive models really complement the natural subjective insight that the field officers bring to the table, or that any program director out there brings to the table. And processes have been put in place many times through individuals' own experience and gut instinct of what is the right thing to do in many cases, and many times those gut instincts are correct. What we're finding is the predictive modeling models help us sort of just tweak and make adjustments to those processes to make them even more successful.
Right.
And I think that's always key.
Danalisa, if you could just talk maybe a bit about this theme of doing this in-house with you and your team versus farming it out to some outside group. Do you think you would have had the same results, or how would you compare the two ways of going at something like this?
Well, very honestly, we've never outsourced, and I don't think we would. So we've done everything in-house, and that's also what's nice about the collective knowledge of staff, where you've been there for a while and you learn the systems and how I mean, every program's different. Truly, annual giving, reunion, plan giving, corporate and foundations, even alumni-based projects like alumni travel and engagement. So I think having in-house knowledge is key. And we've always done it that way. And before Advisor, we've used Excel. We've simple crosstabs. And in a sense, it's great to have these tools. It's possible without the tools like Advisor, SPSS. But what's nice is, and I'll be honest with you, when we ran the data, we tried to replicate the results the way we originally did it, so in Excel, and then just very, very simplistically. And the data was replicated, the percentages are good, and not that we needed convincing, but it was just fantastic to see that as well. Also, it made us feel good that, hey, we can do this, and we're doing it correctly, and trust the software as well. But it makes it's like you said, prepping the data is the most time-consuming part because you want to be accurate and exact. Mm-hmm. Exact is really where you want to be. You don't want to be exact -1. So that's the time-consuming part. But once it's in, it's actually very helpful, and it's quick because it's iterative, and you run it, and you say unclick this, and uncheck that, and rerun, and that's really nice actually, just to have it on that one little panel. The visualization is great. The lift, normally you see a lift diagram with an X and Y axis and the standard random line, and then the curve. But when it's actually in that bar chart, where the positive lift is to the right, the negative is to the left, I've actually shown clients that, and that's easier. That is so much easier for your clients to understand, because truly part of what we do, we're also consultants. So we meet with our clients before the project kicks off. We're doing the logic behind it, and then we're delivering it, because a lot of times for development officers and people who don't do this, and they're not supposed to know, it needs to be explained. There's a lot of work that goes involved, and you want to make sure that the work is being, it's being utilized. So we do a lot of that, and having to show someone that easy bar chart that it's an Advisor is actually so easy for people to understand. So it takes something that's complicated, and it's like, oh, we get it. Okay. So it's a really good. We're very happy that we purchased Advisor.
Hey, Mike, it sounds like you had a point you wanted to make, or
No, my point earlier, actually a question for Dana Lisa. I think she mentioned one of the projects she did with the vet hospital and able to show sort of the impact of not mailing perhaps to a large group of individuals because from the predictive models it wasn't worth the cost, I guess, of sending that out. And I'm wondering, how hard of a sell is that sometimes to program directors, or if she could speak to that a little.
That's a great point because, I mean, honestly, we all manage our colleagues and our personalities, and I think it part of that truly is the buy-in of the people coming to you. And I think what happened recently, actually, which I would imagine affected everyone when the economy took a downturn, we all felt that we all had to be more strategic and plan efficiently. So that, I think, everyone had buy-in. But, I mean, I think if people are a little more, if they're a little more cautious, but you can verify. It's data. It's there in black and white. So if you can verify and just say, this is what we've got, this is what history is showing us, the buy-ins, it's not that hard. It's not that hard. And we don't approach clients by saying, change this program. We just suggest that they look at this and consider. And then honestly, with soliciting the euthanized pet owners, I just said, I mean, you would not believe how quickly that conversation took off. So we need to change that. So I think everyone wants to see ways to do things better and get ahead and cut costs. So it's not too hard to have buy-in when you can prove it with the data.
Now, we've got a couple of questions coming in from the audience, and those of you, there's a control panel on the top right of the webinar where you can put your hand up, and if you do that, we'll note it and then unmute you. We have a question from Karen Isbell from the University of Michigan. So, Karen, let me unmute you. Karen, you should be able to talk, and then both Annalisa and Mike are online.
Great, thank you. So we've got a group sitting here, and we actually have two questions, but if I can only ask one, I'll start with a comment Annalisa made about data scrubbing. And that was actually one of the first things that popped in my head when you showed a little bit of the demo in terms of how much scrubbing of the data has to happen before you can load it into Advisor to start working with it, and how long does that, say you've got 250,000 records that working with.
Doug, do you want me to field that one?
Yeah, well, let me just preface this. So Dartmouth and UPenn probably have different answers because at Dartmouth we've implemented a full set of projects that load the entire advancement warehouse into memory. At UPenn, they're using prepared tables for this specific purpose and don't have the projects with all the data. So take it from two contexts. Annalisa, you first, and then Mike to get
Sure.
different answers on this.
No, it can be time consuming because I think one common theme everyone has is your data is only as good as what goes into your database. So it's not only did every staff member, and we have how many hundreds of development staff members, did they all put in their event data? Well, clearly no. So I mean, so missing data, bad data, and then with the nitty-gritty, it's, well, what does it look like? Are there misspellings? Or, it doesn't look the same, so it's completely, it's just, so yes, there's a lot of scrubbing, but I've got a script, not to say that's automated. I mean, it's just a list I have of things we do, and it's standard operating procedure, so it becomes more routine the more we do it. Is it time-consuming? Yes, but truly, I'll say this, some things are universal across projects, so we'll do the same kind of cleanup. But as each is different, once you meet that, basic criteria of have you scrubbed, then not everything else requires as much, continued high touch. But it is time-consuming. But again, all I was just going to say was the more you do it, it just becomes more routine. It just becomes faster.
And Mike, your
Yeah, similar situation here at Dartmouth, certainly. Because we loaded in what was in our database of record into Advisor, we were able to almost immediately see visually where there were big gaps in data elements. And so one example is going through that financial aid predictive modeling piece. For individual field officer pools, in one particular pool, we came across a very small selection of individuals that hit on the model. And the field officer said that, that can't be true. I know for a fact I've got at least 20 prospects that are terrific financial aid donors or likely financial aid donors. And what it came down to was there were different elements in terms of interest codes, contact reports, and other data that was built into the model that was not being put into the system. So we were able to use Advisor to highlight those big gaps and emphasize, because a lot of times, why do I have to feel, I think folks always feel, why do I have to spend the time to get the data into the system? Who's using it? And this is a clear example of how important the data is influencing decision-making going forward, and how important it is to get the data into the database of record.
And that's actually, if I can just piggyback and say, that's one of the nice outcomes. If you actually can show staff or directors that, you know what, here's your data, but just look at these gaps, that's actually a great impetus to and way to get people more enthused about, well, it should be, and so you do have to do that as well.
Yeah.
Okay. Great, thanks. Are there other questions, or can we ask our second, or you got to jump to somebody else?
Karen, let me come back to you. I'm going to pick up Brian Zive from Mass General, and then we'll come back to you if we get enough time here.
Absolutely, thanks.
Yeah, thanks.
Hi.
So, Brian, you should be good to ask your question.
Thank you. So how, I suppose at one time your prospect research shops were just doing prospect research. So how were you able to find the time and resources to move into predictive analytics?
That's a really good question. I'll just kick this off. It really flowed with where we were progressing through the campaign that we just ended. So beginning of the campaign, we spent a lot of time doing sort of very typical, straightforward research, building of profiles, putting people on the map, sort of on the radar screen, filling out our table of gifts to get us ready to launch that campaign 5, 6, 7 years ago almost. And then we were progressing through that campaign, so we knew throughout there that we found our work shifting more towards a real need to be more targeted and do more segmenting of all these people that we spent the first couple of years of the campaign putting on the map. And so we just found ourselves in need of building models. And so once we got people on the map, we had some time resources to spend doing the segmentation of those individuals, and that's where this particular piece came into play.
Yeah, Annalise, you want to respond to that?
Well, I guess what's a little different here, Penn, is, and maybe not. I don't know exactly how how your shop is structured, but we have a fantastic reports team, and I don't. Maybe it's an exaggeration to say a couple of thousand reports, but we have and again, outside of Advisor, but a standardized report library that's distributed so everyone can run these reports and query the database, and then our reports team can do ad hoc projects, and they're always working very closely with the development officers individually and programmatically. So I would think, we've had systems in place to do the prospect pool identification and the refining, so that was separate. This just, I would say, it was a springboard effect. It's just, that was already in place, and then maybe the theory was, what else could we do? And we have done this maybe we were doing this 10, 11 years ago, just clearly not with Advisor. But we always had this in place. But it's also, it's a recent buzzword, and it's getting buy-in and just a general understanding, because everyone's so busy running their shops that maybe they don't have time. And here we come delivering 4 inches of stacks of paper and great data that we're in love with, and it just maybe people don't have the time or the understanding of what to do with it, and that gets back to we have to work with them. But we have other systems in place, and this is just a great next step. And now that people are more familiar with these words, predictive modeling, predictive analytics, it makes more sense now.
I think you hit on a really good point, is that predictive modeling, the trend is now for any nonprofit to do this type of work and to report back on the effect that gifts are having on the institution and to provide greater objective data on the work that we're doing and how we're putting dollars to use. Certainly here at Dartmouth, with the arrival of our new president, President Kim, and his work with Partners in Health and the work that's being done here at Dartmouth with the Dartmouth Institute in healthcare, it's all about using data to make better decisions. And so there was almost this immediate need. We have to be doing this type of work. And if you don't have time, find the time, because this is really starting to be the smarter way to do projects and to work.
Okay, Brian, thanks for your question. We have a
good question.
Another question coming in from R.P. Shaw at MetLife. R.P., you should be able to ask your question now.
Sure. Sure, thanks. I was actually just wondering, I know the gentleman over at Dartmouth had mentioned that they have kind of their entire system of record database loaded into memory. And maybe a question for both Doug and that gentleman is, what type of hardware kind of requirements are we looking at to implement something like that?
Let me answer that generally.
Thanks.
So we run on both PCs and also servers. So on a PC, a Windows XP, Vista, Windows 7 with like 2 gigs of RAM, an older one, we can fit 600, 800,000 people and maybe 3 to 5 million GIFs and a bunch of maybe 40 other tables that maybe in total are 10 to 15 million total rows. We also implement off servers. So on a 16 gig, which is a fairly standard server with 10, 20 users on it, we can fit tens of millions of rows. It depends on what's actually in the data, but we can hold a lot of data in memory, and we're typically in this world pulling Mike, I think we've got 20, 25 of your Oracle tables coming in, roughly something like that. So there's core information, and there's some descriptors on it. And some of our clients, it's 60 because there's just a ton of tables. They're not as normalized. They may have, these codes that you need descriptors, which are separate tables. So
yeah, we have more than that.
Yeah.
Yeah, and I would also add that we load in everything from our system. Occasionally, like any project, we'll find, it'd be nice to have this particular data set, and, bring that in. And the process for doing that is quite easy as well. So part of our post-campaign planning is looking into, what effect did senior officer visits have on raising gifts, and how many times did the president go on a visit, and what was the result of that? That's not data that we're bringing over on a regular basis, but we have it, and I'm able to just bring it in really just a 2-3 step process. It takes minutes, and then I can begin doing that analysis.
Yeah, and there's ad hoc projects like these, and like you've also got production projects that are out to more people. Like there's a prospect identification one I know that refreshes every night, so it's just at 3 in the morning it reloads with current data, then everybody comes in there that's updated.
Right.
A few more questions. We've got one from Shannon Cadil up at Stanford. Shannon, you should be unmuted and can ask your question.
Perfect. Thanks, Doug. Hi, everyone. So I was curious, from Mike, you mentioned that your annual fund director has access to this tool, and Danelisa, it sounds like maybe it's a little more restricted to the analytics and reports team. So I was just curious if you guys could talk a little bit more about what was behind those decisions for access, and if you have any thoughts about extending it kind of more broadly.
Okay.
Yeah, I can jump in here, Danelisa, just real quick. The initial decision was let's keep it with the researchers and let the field officers be out on the road and not getting caught up in doing analysis, and that makes sense theoretically. They should be out on the road raising gifts. We're starting to shift now in putting it into the hands of the sort of managers of the different officers, and we're beginning to build a performance management and pipeline dashboard as well that the director of major gifts and director of what is called principal giving at many other institutions will have this at their fingertips as well. But just have at their fingertips what's in the pipeline for various fundraising priorities and so on. I think eventually with the launch of things like advanced web, which we're not on right now, we'll have the ability to put at least somewhat restricted dashboards in the hands of individual field officers. That will be a sort of probably a preset number of tabs with a predetermined data set so that they can, when they open up advanced web, for instance, very quickly get a look into what that pool looks like or what activity is going on there.
Yeah, we do have clients that have pushed it out to the front line. As Mike said, though, when they do it, it's usually a very simple dashboard with a few pages and a few charts. And clearly the predictive analytics doesn't go to that level. Okay. Shannon?
Yeah.
Oh, Dana, Lisa, you're going to add on?
I was just going to say, and that's how it's structured differently here. We don't roll it out in the same way. We have other standardized reports in place for basic querying, and so I mean, as far as an analysis, we've got, and again, because we use it just for primarily the predictive modeling, so not the data visualization, the data discovery, and that. So since we've got the technical background and the permissions, and we know how to work with the data in the warehouse, it just makes sense that we just keep it right here.
Perfect. Thank you.
Couple more questions. Yeah, thanks, Shannon. Couple questions. We've got Robert Sanders from Oakland U. Just a second. Robert, you should be able to ask your question.
Hi, how are you?
Good.
Yeah, I have a question on return on investment. The UPenn people and the Dartmouth people, have you been asked to provide any reports to your president or your VP with specific return on investment, saying if we didn't have this predictive analytics project or software, this is how much less philanthropic commitments we would have had?
Right. I think that's a great question. If I weren't sitting here, I would be asking the same thing. That's fantastic. We had buy-in from the start, but I mean, there's always a leap of faith when you're evaluating different software programs and decide which way you want to go. And it's true about you have to spend your money wisely, looking for the ROI. But the first project we did was a $1 million donor. Like, who are the next $1 million donors going to be? So we met with our administration, and it turns out it was a very, very welcome response. And part of that was it returned these names that maybe I didn't know. I don't know every single person in our warehouse, but they recognized. So it just conversationally, oh, it made sense. But then with the data behind it, it's even better. So we had that buy-in. And as far as the cost, we don't have many licenses, so we weren't talking about a big outlay of cash. And like, since we've done other analyses and we have the buy-in, but to specifically say, how can we track it? You want to look at your metrics. You want to say, well, this is what we predicted, and that's great, and it makes sense, and we can substantiate, but the question is, did it come true? So you have to wait a few cycles, truly, to see what's coming in, who's it coming in from, and did those predicted people or institutions really perform as predicted. So it takes a few cycles to actually go back and track your metrics, but you can do that, and that's what we're in right now. We've had this for almost 2 years, and with some of our programs, we can actually now, it takes a while, but have the time and the data behind it and say, okay, how do these predictions work? So you may not be able to prove your ROI right away, but people need to understand that as well, and that's where you just explain, look, this is the nature of the beast. But so far, we haven't had any any resistance.
I'm guessing
we're right at the 1 hour point. If you can stay on, we'll run over a little bit. Let Mike respond, and then we, Karen, if you're still online, we can come back to University of Michigan with your last question if you put your hand up again. Mike?
So in response to ROI, we're moving towards creating an official ROI paper on that, but we have some very clear success stories, one being with our call center here. So we have students calling alumni for the annual fund. Utilizing Advisor, we were able to do a very quick analysis and understand that certain calling hours were not returning the results that we may have thought they would have been returning, and so the director of that calling center was able to reduce the number of hours and realize some immediate savings there. We've also done some very quick analysis here in development on the dispersal of printers for individuals. And initially, I think the IT folks are going to go out and buy all new printers, for instance, and just using the Advisor Visual software and loading up printer data to understand where to shift printers around to save money. So, and then within 2 months of us doing a predictive model on next $1 million donors, one of the individuals that popped up in that model ended up giving $1 million. So we had an immediate success story there. What we need to do is then take the next step now, put all these stories together and build that ROI report.
Great. Hey, so we've got time for one more question. Karen, I'm going to, from University of Michigan, bring you back. You can ask your second question.
Great, thank you. So very quickly, we actually had one question from our group here about the type of regression analysis that the system does, or are there multiple, multiple varieties of regression analysis that are available within the system, or is it sort of a one deal?
Right. So we have one regression algorithm. It's from a company called KXCN, which is one of the major players. We've embedded that in the software, and we can give you more. We'll make a note to send you more detail on it. But what we've tried to do is package it so that people, who are not the trained statisticians can select data and just point and click and use it. So if you contrast this with a SAS or an SPSS, for example, they have a much richer set of algorithms, many more options, but you have to know a lot about modeling because you have to pick the right model and algorithm. You have to do a lot more prep on the data, and then the answers come back in the model. You don't actually have all the data. We try to make this so it's a point-and-click experience, which has restricted degrees of freedom, but in the theme of simplicity and more people can use it.
Great. Thank you very much.
So we're over time. Appreciate all of your attendance. We will be following up with a we've recorded this so you can show it to others, and if there's additional questions, get them back to us. And I know a number of you typed them in on the chat line. We'll be responding all of those offline in the next day or so. And I want to really thank Dana, Lisa, and Mike for the time today and the work they've done in being willing to share it with the whole group. So thank you both very, very much.
Thank you.
Thank you.
Yep, and take care. Thank you very much.